In this video, we are going to learn how to use the k-nearest neighbor algorithm for classification. The example that we are going to use would be classifying suppliers as partners based upon some attributes which are on-time delivery rate, average lead time, order volume, production utilization, and the region in which the supplier is located. So let's get back to KNIME and start the process. So I will bring in the Excel reader node and let's read the data file first. So the file that we want to read is supplier partnership file, which had the attributes which we just saw. We have to ensure that the column serial number is excluded from being loaded. Otherwise, it is going to be used in the analysis, but it is just for identification purposes. We do not need it in our model. Let's execute the node and verify that we have the table loaded. So here is that table which has been loaded in KNIME. If you notice, the column region is of string type and it contains west, north, south, the strings and not numbers. And we know that k-nearest neighbor works on the basis of calculating distances between numeric attributes, but we will see how we will handle this in a moment. Let's partition our data set into two parts. Let's keep 70% for training and the remaining 30% we will be testing. Again, let's choose stratified sampling on the basis of the outcome variable. And now let us pass on the first partition to the k-nearest neighbor node. And let's configure this node. So we are going to predict the column partnership, which had yes or no, based on these number of neighbors. K is the number of neighbors to consider. Let's change that value to 5. So we are going to consider 5 nearest neighbors for making the classification. And if you notice, the second input connector requires you to connect the test data to the k-nearest neighbor node. So let's do that. So now we have the classifier being built on the first partition, which was the training set, and the class labels for the test set will be determined by calculating the distances and then figuring out what was the class of the nearest neighbor. So let's run this node. If you notice, there is a small little yellow triangle that has emerged and which says that the input table contains more than one non-numeric column, they will be ignored. So if you recall, the column region was of string type, which had south and west, etc., not a number. So that column has not been included in the analysis. And we will see how to handle that in a moment. So let's add in the scorer node in order to look at the results. So when we look at the scorer node, we have to provide the actual and the predicted column. So the first column is the actual partnership column, which was already there in our data set. And that is going to be compared against the second column, which is the class which has been determined by the kNN algorithm. And when we run the scorer node, you will see that it gives us confusion metrics and accuracy statistics. We will straight away jump on to accuracy statistics as it already contains the confusion metrics. And let's take a look at that. Now we can see there are a lot of columns here. Let's get rid of some columns and look at only the ones in which we are interested in. So I'm going to pass on that accuracy statistics thing to the column filter so that I can filter out the columns that I don't need. So I do not need this, I do not need this, and also these. So let's just get rid of them. So we will be left with the 4 attributes of the confusion matrix: precision, recall, and accuracy. And let's execute this node and take a look at the output table. So here we are. Please remember, we have to focus on the first row only because our class of interest is yes. We want to predict if a supplier is a partner. We will not be looking at the second row. So in yes, there are 6 true positives, 2 false positives, 6 true negatives, and 1 false negative. This is based on the test set that we had already partitioned. So the test set contained 15 rows. So these classifications have been done on the basis of those 15 rows. And the accuracy that our model is getting is 80%. And these are the precision and recall values for the case. Okay, having done that, let's now focus our attention on this problem that we had here, that one of the attributes was containing non-numeric values. Let's see how we could fix that. So before partitioning our data set, we need to transform that column. So to do that, I'm going to connect my Excel reader node to a node which is known as the rule engine node. So when I configure the rule engine node, this is where I can play around with my variables. So the variable of interest was region. And you can see that S here stands for string. So this is a string type. I will double click on region and it comes over here. So the way to do that is if region is equal to and within quotes, since it was a string, I'm going to put north and then is equal to and greater than sign and let's put 1. So what that means is wherever it finds the region as north, it is going to replace that with a 1. And let's copy it because we need it. We need to do the same 2 more times. So we will have the value 2, let's say for the west region and the value 3 for the south region. Now I want these to be appended as a new column and that column's name should be region underscore num or region numeric. You can give it any name you want, but we are using this name for identification that this is now the region converted to a numeric format. So north will be replaced by 1, west will be replaced by 2, and south will be replaced by 3. And let's click OK and execute this node. Let's take a look at the resulting table. So now you can see that west has been replaced by 2, north has been replaced by 1, south has been replaced by 3. So we have added this numeric column in our data now, and now we will also be using region in our classification. Previously, it was being ignored because it was of the type string. So what I will do now is simply connect the rule engine output to the partitioning input and repeat the process. So let's do that. And then let's do that here. So if you recall, it is still telling me that the input table contains more than one non-numeric column, although I had transformed that to a numeric column. But the thing is that string column was not removed from being included in the analysis. So let's do that first. Let's do that. I'm going to disconnect this node and I'm going to give the output of this rule engine to my column filter. So now let's remove that column region from the analysis. So it is going to only include those variables which were numeric and of course the outcome variable. Right now, when we connect that to the partitioning and that once again, this time if you notice that yellow triangle has disappeared because that non-numeric variable was excluded from the analysis. And let's take a look at our classification now. Results now. So now you can see that the accuracy has dropped to 60%. Well, every time we run this analysis, it performs a partitioning, it selects a new sample. So based on what it has selected, these things are bound to vary. Let's reset all nodes and then let's execute all nodes once again. So this time another partitioning sample would have been determined. And let's look at the results now. So now you can see the accuracy has improved from previous 60 to 66.7. So like I told you, this is simply based on a new sample which is randomly generated for the test case every time. That will be all for this session.